Last video we talked about hysteresis design procedure for a non-inverting input. It's right here. If you haven't watched this, please watch this video. And this time, let's talk about in my opinion, it's a more interesting circuit for the inverting input. What that means for a comparator, the input is on the negative side. Okay, it's on the inverting side. And the design goals, it's quite simple here. We want to design hysteresis and with 15 millivolts and the reference point and the middle of the power rail, which is 2.5 volts. And the VCC is 5 volts. The output max is at the VCC level. That's the output here. So 5 volts, and the output mean the minimum output when the state change from high to low, it cannot go quite like 0 volts, go like a 50 millivolts low. And R1, which is the input resistor here, is 10K, and our pull-up is resistor. It's a pull-up resistor in case the signal is floating, the output is floating. And before we go into the calculation, I want to mention this is from Texas Instruments online training video. What I'm doing here is basically just explain the calculation in details, which they didn't. And just recap the hysteresis design, because if this is ref, this is the actual voltage you want to compare to. But in reality, we have two thresholds. I call it V high and V low. Okay, and for a inverting case, because the input is in the inverting, so when a signal from low go high, when the signal cross V high, the output is V. The output is V min, it's minimum output. Okay, and when the signal cross from high cross V low, the output actually is at the max because it's inverting. Okay, and just look at this diagram here. What's in terms of design principle? Let's ignore the feedback resistor. Remember, this hysteresis design, it's a positive feedback, and let's ignore R3. And we want to set the reference voltage to 2.5 volts. What we do, we have a 10K here, and the VCC, that's the 5 volts VCC. So we have our 2 also 10K, just have a 1-to-1 voltage divider, get the 2.5 volts. That's very straightforward. Now, let's see, how do we decide R3? Because R3 is actually introduce these two threshold values. And by the way, the difference between VH and VL between this is a hysteresis, which is 50 millivolts in this case. To decide R3, what we need is draw first maybe draw a equivalent circuit over here. Basically, it's a equivalent circuit with 3 resistors. We have VCC and R1 and R2 go to ground, and another branch we have R3 here, and which goes to the output. Okay, let's talk about the case when V in is low. That means V in just drop to the low side. Okay, when V in is very low, we know the output is at V max. Okay, but when V in is low, because that means because V in crossed the lower threshold, the V1 to the hysteresis at this moment will be V high. So this node should be V high in this case. And by the same idea, we have a similar circuit for the other situation. R3 here, VCC, if the V output is min, that means the V in just above the high threshold, and the output flips to the minimum, and And the threshold, in this case, we want to add V low. Okay. Once we have these two circuitry, we can just use a current long. So we know the current flowing here, current flow this branch should be equal to current flowing through here. That means VCC minus VH divided by R1 plus the current Vmax minus VH divided by R3 should equal the total current, which is VH divided by R2. Okay, VCC minus VH, that's the voltage difference between this resistor divided by R1 plus the current and R2 should equal the total current and R3. So by the same idea for this circuitry, we have this equation VCC minus V low R1 plus V mean minus V low divided by R3 equals V low divided by R2. And to simplify these two equations, we just use one equation. Let's use equation 1 to subtract equation 2. What we get is we got R1 still there, and the VCC cancelled, and here we got is minus V high plus V low plus R3 and V max minus V mean. That's the difference between the output, and minus VH high plus V low, and on this side is V high minus V low and R2. So the goal is we want to get R3. So let's move this to the other side. So we left over is V max minus V mean minus V high minus V low. I put the V high V low into a bracket, so change the sign in the middle, then divide by R3. And this move to that side, we have V high V low R2 minus R1 minus V high plus V low. Okay, let's move this side, change the sign. We can plus sign here and the minus sign here. So minus sign here. Okay, and in the numerator we'll have V high. We can take the V high minus V low out, and inside here we left over is 1 over R2 plus 1 over R1. Okay, which is equals this is can combine R1 R2 to R1 plus R2 R1 times R2. Okay, and we want to get is R3. So what we can do is use R3. R3 to use R3 will equal this whole term here. R3 equals we move the R3 to the other side, and then just use this whole denominator here. We mean minus V high minus V low, and divide by this term. Okay, so that's V high minus V low in the bracket, and R1 plus R2 R1 times R2. Okay, so let's move this outside. So what we have is R1 R2 plus R1 times R2. So what we left over is V max minus V mean divide by V high minus V low, and minus we have V high minus V low divided by V high minus V low, that's 1. So we just simplify this equation like this. And remember, as we mentioned here, V high minus V low, which is V hysteresis. So this is R1 R2 plus R1 plus R2, and divide by R1 plus R2, and V max minus V mean divide by V hysteresis minus 1. Okay, this is R3. just remember this equation, and if we check it back to this equation here, that's exactly what we get. It's basically R1, R2 in parallel, because this looks like you inverse R1, R2 in parallel, and the difference between the output high to low divided by the hysteresis value and minus 1. And so if you want to get the value for R3, and you just can use R1, R2 values and put in equations. And for this example, which you got 490K. Okay. That's basically all the calculations to show you how do we get to here. I think the key to understand this is when the signal have to flip the states, the signal can have when the signal from low to high, you have to cross the high threshold, and from the signal go from high to low, you have to cross the lower threshold. Okay, and the R1, R2 sets the central reference voltage, and the feedback loop works with the parallel resistance of R1, R2, and work like a positive feedback, and give you this hysteresis. And the value will change if it's either high or low, because mainly it's because the output is flipped state. Okay, that's the magic, because the output also flips the state. That's why this equivalent circuitry here, all the resistor can set the high and low threshold values. I hope this can help you to understand this, and thank you for watching.